education and the research areas of our department, AU Energy, and I will try to introduce how we can implement this help kits in one of our master courses. This is associated with this embedded microprocessor. And finally, I will try to show some results, like the questionnaire we sent to the students after this course, and to see what is the feedback from them. Yeah, so first of all, about Aalborg University is basically here you can see this is the map of Denmark, and actually Aalborg is located at the north part of the Denmark, and Aalborg University is of course located at Aalborg. So Aalborg University is a relatively young university. It's established in 1974. And right now, we, besides the division in Aalborg, we also have another two campus. One is in capital city Copenhagen, and the other one is in Esbjerg. So in terms of the size of our university is that right now we have more than 22,000 students, and in terms of the faculties, we have more than 2,000 faculty staffs. Yeah, and even though Aalborg University is a relatively young university, but see from these rankings, we have a very good performance. Especially one example could be from this US News ranking, and in terms of the engineering, we are ranked at number 6 globally. And if we see from the Europe, then it's number 1. And the major I'm working on is about this electrical engineering. And if we talk about the global ranking for this electrical engineering, then here we can see that Aalborg University is ranked as number 3, according to this US News. And another thing, maybe one feature of this Aalborg University in terms of teaching is that we have this PBL model. We also call it Aalborg model. So what is the meaning of this PBL is that we try to produce this problem-based learning. And then in this kind of the training model, so basically students normally will work within a group with 4 to 6 students, and they will try to solve practical issues each semester, and they will try to report their results during this oral defense. And about the department of the energy where I come from, so basically we are trying to deal with this energy. So this energy, we could see that it includes the production phase, distribution phase, and also the consumption phase. So here, basically nowadays we could know that from the production phases, these centralized power stations are no longer needed anymore, and more renewable energies, especially in Denmark, like wind power or solar energy, is introduced. So here that means more and more power electronics is involved in terms of this transformation, because we know that for the power grid we have the fixed frequency. Well, if we talk about the energy that is generated from this wind turbine or PV, then it could be either the frequency is changing or it's a DC power. So here we need to use this power interface in between, try to do some change between these different interface. And then see from this consumption phases. So basically, for example, if we talk about this motor drive or these power supplies, so here we need to still use some power electronics in between to change from the utility power to the powers that is preferred by the different users. And it can either be, for example, motor could be the AC voltage, while the power supply like this laptop could be the DC voltage. And then recently, this power electronics is also very involved in different areas, for example, like the power to X. So here we need to use these electrolyzers, try to change these energies to the hydrogen, for example, to store this energy. And the other hot area is about this electrical vehicle. So here we still need to use these power electronics in between, try to charge or discharge the batteries depending on the status of this electrical vehicle. Yeah, and then about the education in Aalborg University is that here we both have this master program and also this bachelor program. And for the bachelor program is actually a 3-year project, 3-year program. And if we take an example from this AAU Energy, it's to talk about this energy engineering. So here we could see that in total, so students have 6 semesters, and each semester they need to earn 30 ECTS for each semesters. And once the student becomes senior, and from the third year, they will have the different research areas like electrical engineering, electrical energy, thermal energy, and also this mechatronics system. And then afterwards, if we want to go into this postgraduate program, so here we have this master degree as well. But in here is a 2-year project, and then at the first semester is based on these 3 majors we defined at the bachelor level. So here the master student may have the possibilities to change to more specialized directions. For example, if we talk about this electrical energy engineering, so here we have 3 directions they can choose from. For example, the power electronics and drives, and also the wind power system, and also the other one could be the electrical power system and the high voltage engineering. Yeah, and it's the same. If we talk about the ECTS, and then it is the same as a bachelor's program. That means each semester students need to obtain 30 ECTS to finish this curriculum. Yeah, and here the course we link to this help kits is actually a master course that is located in department of the materials and production. And here, if we talk about the major, is it's called electrical mechanical system design, EMSD. And if we take a look at the 1 semester course from that, so here basically we could see that the student need to take 3 courses to have some basic understanding of this program. And meanwhile, it has we have 15 ECTS project based. So that is the link to the PBL we mentioned before. So that means each semester students need to work on define the project based on some practical issues generated from the supervisor, and then students will work together try to solve these issues. Yeah, so the course we are going to talk about this embedded microprocessor application and C programming. And it's actually a 5 ECTS course. And if we talk about the learning objective from this course, is that first of all is some languaging skills, like in case of this microprocessor. So normally we are using this C or C++ program. So the first part of this course is linked to this basic language programming. And then afterwards, we have an application case that is used in this microprocessor. We call it the digital signal processor, DSP. And so here in this course, they need to understand what is the architecture and what is the basic operation principles for this microprocessor. And finally, is they need to learn how to program these peripherals, that there's some interfacing of this DSP to see how we can use this C programming to control, for example, these GPIO or ADC conversion, some modules that is used in these DSP kits. Yeah, and about some hardware that is linked to this DSP course is that first of all, of course, we need to have these DSP kits. And here, this DSP kit is actually consists of the 2 parts. One is this development board. So for this board is actually we have this our TI DSP called the F28069, and that is mounted on this PCB, and it also has the base minimum operation system that is ready for this DSP to connect to our laptop. And afterwards, we also have this booster pack, and it's actually located on the top of this development board. And here for this booster board, actually we have the possibilities to have a joystick to use that as a ADC input, try to change the positions of this joystick. And meanwhile, we have some LEDs to show what is the control signals for this LED, and we also have some push buttons and also some buzzers and even LCDs to show to try to extend the functions from these DSP peripherals. And meanwhile, we also need to use some equipment to measure the results. So here we are using this picoscope, and this picoscope is actually looks like this. And the function of this picoscope is actually it includes two parts. It can either be used as input or output. And in case it used as an input, so here we have two channels of this BNC cable that could be possible to see the waveforms of this current or voltage. And an alternative is that if this picoscope is used as output, then it can also be served as a signal generator, for example, to generate some signals like this triangle signal or this sinusoidal signal. Yeah, and what we try to do is here we also try to use this help kit that is developed in this project and try to link to this help kit to these courses. And here, basically, we could see that for these help kits, we have the possibilities to have the different power supply from this plus minus 50 volts. And meanwhile, we have some push button and also some LEDs to control. And on top of that is that we still have this breadboard. And in this case, if the student has own circuit want to test, then it also have the possibilities to design this circuit by themselves. But here in this project, we are mainly use these LEDs and the power supplies from these help kits in order to learn how this DSP can be used to control this LED in a different pattern. And if we take a look at the basic function of this DSP, so here basically we know that for DSP is compared with this a computer is not only have this CPU part and also this memory part, which include of this RAM and ROM, which have the different possibilities of the write and read possibilities. And the key feature of this DSP is that we have a lot of peripherals. So what is peripherals? Basically is that, for example, if we talk about this ADC, that means analog to digital conversion. So here for this ADC, we could try to measure some signals from the outside world. Then we could try to change from this analog signal to the digital that can be handled by the DSP. And meanwhile, we also have this, for example, these EPRAM units that can be control a different voltage level with a different frequency and duty cycle. And in that way, we could try to drive, for example, the brightness of the LED or the frequency, the lighting frequency of this LED. And besides of these peripherals, it also have, for example, if the DSP want to talk to another DSP or the laptop, and then here we have a different communication skills like the I2C or SPI, SCI, SPI for the communication skills. And more important is that we also have this general purpose input and output GPIO in order to try to receive some signals from the outside and also try to put some high voltage or low voltage in case we want to control some switches or some light LEDs, for example. Yeah, so basically, and the student need to finish this mini project before they go to this oral examination. And here basically we design, because as I mentioned before, we have the C programming part and the DSP part for these courses. So in total, we designed the 4 mini projects, and 2 of them are linked to C programming and 2 of them are linked to the DSP. And here I list the 2 cases that is linked to the DSP. One is this analog control of this microprocessor. And the idea of this mini project is that actually if we want to change the position of this joystick, as I mentioned before in this booster pack, so here we have the one possibility is to controlling x-axis, and here this x-axis can be linked to what is the duty cycle of this PWM, and that will link to how brightness this LED is turned on or off. And if we use this y-axis, then here if we change the different value of the y-axis, then we could try to change the frequency of this PWM. And then we try to use some modules inside these DSP kits, like this ADC module or this PWM module. And then if we talk about LEDs, then we try to use this PWM to drive the LEDs that is located at these help kits. And meanwhile, we also have a push button, and the purpose of this push button is that because here we have 3 LEDs need to be controlled at these help kits. So here we could use this push button to change, for example, once this push button is pushed, then we could have the possibilities to change another LED. So this is a case for this analog control of this microprocessor. Another thing is another mini project is called this motion detection system. And here in this mini project, basically we still want to control this LED at this help kits. But the idea is that here, since we have this accelerator meters to measure the motions of this DSP board from this X, Y, Z axis. So here, once if this accelerometer detects some motions from the different direction, so basically each of the different LEDs will be driven on, and here we still use and here we trying to use this timer. For example, if we detect this motion, the motion is stopped, and if it lasts for 5 minutes, then actually we will try to turn off this LED. And then we also have kind of this emergency stop, is that if within 5 seconds, if we want to turn off this LED, so here we have this push button. And once this push button is pushed, then this LED can be turned off immediately after this push button is pressed. And then, meanwhile, we not only this LED is turned on, but also we have the buzzer that need to be controlled by this PWM to show us whether this DSP kit is stand still or is under movements. Yeah, so actually we have 13 students that select these courses, and in total 11 out of them are selected these two mini projects, and they actually can both drive these LEDs in the help kits in a very good way. Yeah, and then third part is we also try to receive some feedback from the students after this course is finished. So we sent some questionnaires to them to see what is the impact of these help kits. So they are basically divided into four directions. So first part is about these skills related to this module, and first question could be, for example, how would you access your skills necessary for this model? So here, basically, we could see that the majority of the students think these skills are very necessary for this module. And if we talk about the motivation of this to use these help kits, and the answer is not that good, as the students maybe not know very clear what is the motivation of this to use this help kit, but it's understandable because previously we don't use these help kits to integrate in this course. And we also have the LED, but it's already located in this DSP kit itself. So yeah, the students miss a little bit of the motivation of these help kits. And here we also, I forgot to mention that here 8 students participate in this questionnaire, even though we have 13 students. Yeah, but if we talk about the results for these possibilities to use these help kits to improve their skills, so it's relatively good because most of the students choose these help kits have the potential to improve their skills in the different ways. And about the influence of these help kits, then yeah, as I mentioned before, since previously we don't involve help kits at this course, so students may not think these help kits is very useful to further or better understand the topic of the module. So here is some results, and yes, about the values to use these help kits, then yeah, students also didn't. Yes, the result is not as good as expected. And then the second part is about the collaboration and the peer learning from these help kits. And as far as I remember, is that for the help kits, it's actually developed during these COVID conditions. So actually, it's not have a very necessary impact to increase cooperation between the students. So here, if we take a look at the results of this survey, so here we can see that yeah, it means that it's do not facilitate the collaboration between the students if we use the help kits, because normally these the student can handle the help kits by themselves. Yeah, and about the using experience of these help kits. So, for example, if we talk about how smoothly this distribution looks like in order to distribute the help kits, and a lot of the students think it's good, and the help kit is also easy to use. But if we talk about the guidelines of these help kits, and here maybe I didn't use so much time to advertise this help kits manual. So here says maybe the students didn't have a careful look at the user guide, so they don't think this user guide is very useful at this at current stage. And the help kits is also very work well with the laptop. They have the very good capabilities to control, because previously this DSP kit is also linked to this laptop, and here we have this help kit, and they can work very good with this laptop as well. Yeah, and then yeah, about the content and also some difficulties when they doing some experiments. Then here I think we still have some potential to improve for these two parts. And about to use help kit to help the student to understand this topic. So here the student didn't got very clear answer, but it's understandable, because as I mentioned before, this help kit is not highly involved in the previous courses in this EMSD. But of course we can do some improvement later in our course. Yeah, and try to compare these help kits with the standard laboratory equipment. Then here, students don't feel any advantage, because maybe I think students is not familiar with the ordinary system with this DSP, because previously, if we talk about the DSP kits, then they already don't depend on this laboratory facilities like this power supply. It's already help kits that is linked to laptops, so maybe yeah, they don't have a very fair comparisons with this standard laboratory equipments. Yeah, and the help kit is relevant to this learning module we talk about. Yeah, and for the last survey for this help kit is that do the students think these help kits is very time consuming to use? And I think most of them thinks are okay, but Two of them think it's easy to use, so I think it's good for the student to use these help kits. Yeah, so this is basically all from my side. Thank you very much for your listening, and if you have any questions, I will be very glad to answer.
We do have a question from Brian Mulligan. He wrote it in the chat. I can read it to you, Dao, if you want.
Yeah.
He's asking, is C programming a prerequisite for the students to perform this module, or is it included in the course?
Can you repeat the question?
Sorry. Your sound is cracking up.
Okay, so can you hear me better now?
Yeah, that's better.
Okay, so yeah, the question is C programming a prerequisite, or is it included in the course?
Okay, for these help kits is actually already developed by the manufacturer, so the students don't need to be. Yeah, it's only some software need to be installed as a laptop. For example, this CCS code composition system that is used as an interface to link between these help kits and the DSP kits and laptop. And otherwise, yeah, it's just a microprocessor and with some minimum supporting system like the power supply and the emulators try to have the possibilities to link between this DSP and laptop.
Okay, I saw you have your hand raised, Brian. I just read the question, but maybe you want to say something else. I just read it because you wrote it in the chat, and I wasn't sure if you wanted to speak or not. But feel free to speak, of course.
No, I have a whole bunch of questions. This is a very interesting project to me, and I have a whole bunch of questions, but I don't want to hog it. But what I'm interested in the actual course, and it struck me that a lot of the responses from the survey were mixed, we could say, and to some extent that may not be the fault of the kit itself. It may be that the course wasn't designed to take advantage of the kit. That could be an issue as well. But I have a bunch of other questions, but I'll keep them because others may want to come in.
Yeah, I do agree with you because for this course, it's not a newly course that is poorly designed for these help kits because it's already exists. So the idea is that we try to implement these help kits, try to get this help kit involved in these courses. So maybe they are, yeah, the students from the survey, we can also see that the students maybe don't very see clearly what is the motivation of these help kits, but at least, yeah, because from my understanding is that it's also a good experience for them to play with the other kids, try to control this LED at this help kit.
Martin, you have your hand also raised. So go ahead.
Yeah. So Dao, I'm really interested in two things. One is the project-based learning approach, and how help fits into that. So the first question is, previously, did the students always take the DSP kit home with them?
You mean who made this DSP kits?
Yes. So did they bring them home, or did they only operate them in the university?
Actually, it's actually two phases because for our course in Aalborg, it's normally we have 2 hours lecture and 2 hours of the exercises. And after the lecture, then students will work at their group room to play with these DSP kits. And then if they have the further interest, they also have the possibility to bring this help kit or DSP kit home because we have the plenty of the DSP kits and it's not that dangerous for students to play with it individually.
Okay, because one of the things about help was to allow them to do work at home, but I guess this particular module they could already do a lot of the activity at home anyway. It's portable.
Yeah.
And then the other question is related to how the students take the project. So you showed us 2 projects.
Mhm.
How many of those projects will they do in the semester in the module?
Yeah, it's a very good question because generally speaking, is we have, for example, a lot still the supervisors will provide, maybe if we have 10 students, then maybe 5 students group, for example, then the supervisor will provide maybe 6 maybe up to 10 proposals for them to select it. And then yeah, and then the student can of course we have a overall focus for this our learning objective for this semester, and students also have the possibilities to choose what they are really interested in to work on this project.
Okay, and how much freedom do they have? You know, like when they, so you give them the sheet, I guess, that you showed us.
Yeah.
Describing the project.
Yeah.
And then do they have the freedom to make their own I'm really curious about how they explore the solution and
yeah, because normally it is the supervisor who define this project and also maybe some objective of this project. But of course, the students have the freedom. For example, if they accomplish this objective, and if they have some further ideas, so one idea could be, for example, they can provide some extra work based on this project, and the other solution could be, for example, they can negotiate with their supervisors maybe for the next semester project. Then they could have their own source or idea for how this what is their project can be further studied.
Yeah, because I see some of the best potential for help in that additional part where they can connect on their own external sensors, power them up, make it on the breadboard and interface to the DSP. So it gives them a bigger, a wider option in terms of what they select for their project expansion.
Yeah, exactly. Maybe the next step is that we could also try to involve this help kit in this project as well. Then the student have the possibilities to design some circuit in this breadboard and try to add to DSP kits or something.
Yeah, and that would be very interesting.
Okay, are there any further questions? Go ahead, Brian.
I have a whole list of questions.
But Brian, can I say, maybe you should contact me at some time.
Oh, I will.
We might discuss
here
it.
now.
Yeah. Just
or pop your email address in the chat, and I'll give you a shout. Now, I'll tell you where I'm coming from in this and why I'm very interested in this project is I've just recently retired from the university I've been in, and I was working on an unfunded project which was to bring low-cost engineering education to low-income countries. Specifically, we had a 2-year engineering program in control engineering, which this is bang in the middle of, you know. So, I mean, the idea is to build a bunch of 5-credit modules or courses that would be freely available, and then students could apply to do assessments or examinations at a fee. But a lot of the control engineering obviously needs access to equipment. So I'm very interested to know, can we design or even specify sort of low-cost kits that could be purchased by people primarily in Africa and India would be the two, but we also have people interested in this project in Lebanon and other areas as well. So I suppose my question is, could we configure this course, and it may need to be more designed to go into the course and the kit so that it would be suitable for self-study students in these developing countries? Any open it to the floor. And I'm sorry if I'm hijacking the debate or the discussion, but I think there's huge potential in this work to have even a bigger impact than just a relatively small number of students on a campus. that we can have a bigger impact in the developing world with this type of work that you're doing?
This is a really interesting question, and actually, if for this help kit development, we actually have our Romanian partners who is responsible for develop of this help kits. I don't know, maybe Martin, you may have some comments about how we can, for example, reduce the cost of this kits, or some thoughts about that.
Yeah, I mean, so cost was a huge factor in this. It was a COVID response, but if we want to have one per student, then the cost has to be low. So currently, it's probably about 250 euros to get a kit. But we're also working on control kits as well, Brian. You'd be very interested in the stuff that we're doing on the control kits.
The one thing that struck me is that the amount of topics that you could cover with the students with that kit, and maybe with more components as well, would be worth way more than 5 credits. In other words, you could build a 30 ECTS micro-credential. You could do a lot more with it. 250 is quite expensive for the equipment for a single 5 credit module, but we could do a lot more with it.
Yeah. And as I said, we're working, as it happens, MTU is working on another project to make really low cost control kit.
That's very interesting.
We're controlling it with an Arduino, so that's low cost. But in this scope, we're probably not targeting the really low price that you might be targeting if you're saying into a developing country. We're targeting something that a university in Europe, the burden that they might be able to carry.
I mean, I am also talking to people who would like to set up outreach centers too. So low cost equipment that could be shared between students would also be helpful as well.
But certainly contact me. I think we could have a good conversation.
Okay, right. Yeah.
So.
Thanks for that.
All right, well, no need to apologize for making so many questions, Brian, of course. Thank you for coming. Thank you, everybody who attended the webinar. And I think we can conclude it if there is no further questions. So again, thank you very much for your attention. Thank you, Dao, for the presentation and sharing your experience with us. And remember, in around 2 months, we will have a new edition of these webinars to present one of the other members' experience or use cases with the help kit. Thank you.
Thanks, Dries. Thanks, Joe. Take care.
Thank everybody. Bye-bye.
Yeah. Bye-bye.